Entropy. Entropy is a measure of disorder in a system. The bigger the entropy, the more the system is in disorder. The universe always favors a maximal disorder. In other words, any reaction that increases the disorder of a system is favored and will be able to happen spontaneously. For example, take a pile of books on a table. If the pile falls on the floor, which is more likely? For the books to land in a neatly stacked pile or in a mess? Obviously, the books will be spread out everywhere in a disorderly mess, so we would see the pile on the right. This is a simple way of showing that the universe always favors high disorder. Multiple factors can influence entropy, like temperature and pressure. Different states in nature also have different entropies. To visualize this, think about molecules of water. In the form of ice, water molecules are almost still. In liquid water, there's a lot more movement, and in the gaseous forms, molecules are free to move around quickly and collide with each other, creating a lot more chaos. The gaseous phase is therefore the one with the highest entropy. Here, we are looking to find the chemical process that increases the entropy of a mole of the compound in question the most. Our options are the freezing or evaporation of water, or the sublimation or the deposition of iodine. To answer this question, we need to identify which changes are the most extreme, or in other words, which states are furthest apart from each other. For example, a liquid that turns into a solid or a gas is undergoing a small change compared to a gas that turns directly into a solid. Let's start by defining some terms. Freezing is passing from a liquid to a solid. Evaporation is going from a liquid to a gas. Sublimation is going from a solid to a gas. And deposition is the opposite of sublimation, since it's going from a gas to a solid. The freezing of water reduces its entropy. The disorder of water is bigger than the disorder of ice. To have a more visual explanation, ask yourself this question. Is it easier to contain water or ice? It's definitely easier to contain ice than water because ice is solid and can even just be held in your hands, whereas holding water is almost impossible without a container to keep it in. The entropy change is not really that big, however. We're only passing to a phase that, according to the order of the phases based on the energy of the molecules, is directly beside it. Same thing goes for the evaporation of water. But in this case, there's an increase in the entropy because water is less chaotic in liquid form than when it is a gas. The difference between the disorders of the gaseous and liquid phases is bigger than the difference between the disorders of the solid and liquid phases. We can explain this fact because solids and liquids are in phases in which matter is confined to a certain amount of space, whereas gases can move around indefinitely and at very high speeds. However, going from a solid to a gas is an even bigger increase in entropy. Sublimation and deposition of iodine are left. Both these phenomena involve a very big entropy variation because they are passing directly from solid to gas or gas to solid without passing through the liquid phase. However, deposition brings a decrease in entropy, not an increase, because all of a sudden the molecules are almost not moving at all, so the system is a lot more ordered. Sublimation, passing directly from solid to gas, allows the molecules to occupy way more space and move around very quickly. Therefore, the change that increases the entropy the most is the sublimation of iodine. If we looked up the values, we would find that the entropy of solid iodine is 116 joules per mole Kelvin, and the entropy of gaseous iodine is 260 joules per mole Kelvin. By going through sublimation, the entropy is increased by 144 joules per mole Kelvin.